Okay, so today we are going to discuss the January 2022 Statistics 1. Shall we start with the first question? Okay, read the question number 1. A factory produces shoes. A quality control inspector at the factory checks a sample of 120 shoes for each of 3 types of defects. The Venn diagram represents the inspector's results. A represents the event that a shoe has a defective stitching. B represents the event that a shoe has a defective coloring. C represents the event that a shoe has defective soles. Okay, so these are 3 types of defects. One of the shoes in the sample is selected at random. Find the probability that it does not have defective soles. Okay, so where do we have defective soles? Defective soles is in is the error type C, right? So the type C. So what is the probability it does not have defective soles? How do we find that? So basically what you do is first you find the probability, first you find the number of shoes that have defective soles, and then you can subtract it from the total number of shoes. We have 120. So what's the, how many shoes have defective soles? So basically all the shoes that fall to which category? C. All the shoes that fall to category C have defective soles. Okay. So how many is that? Can you all add it? Part A, defective soles. How many shoes are there? So you have to add all these in the C category. 3 plus 2 plus 5 plus 7. How much is it? 3 plus 2 plus 5 plus 7 is 17. Can you all add? Then we need the number that do not have. So that does not have defective soles. So does not have. It's just 1 mark. We don't need to do all these. So probability it does not have defective soles is what is the how many shoes are there? So all you have to do is what? Subtract 17 from the total number of shoes. We have 120 shoes. So 120 you subtract the 17. How much is it? How much is it? 120 minus 17 is 103, right? So 103 out of how much? To make it a probability, you have to divide. Divide by what? 120. So the answer is what? 103 out of 120. I think it doesn't simplify. So that's it. Okay, just 1 mark. You could write this immediately. You don't need to even write this because it's 1 mark. You could do it immediately. Okay, part C. Part D. Find the probability A intersection B intersection C dash. Okay, how do we find the probability of A intersection B intersection C dash? Okay, basically what I'll do is, shall I do my numbering of the regions? Okay, so let's say this is region number 1, region 2, region 3. So this is the way I'm doing. You all can do it in any way you want. 5, 6, 7, and 8. Okay, so these are the region numbers because I want to find the region that's common because it's all intersections. So basically the region that's common to A, the region that's common to B, and the region that's common to C dash. Okay, so what are the regions belonging to A? Quickly. Region 1, 2, 3, and 4. These are the regions belonging to the circle A. What are the regions belonging to circle B? 2, 3, 6, 7. 2, 3, 6, 7. And then C dash. What is C dash? C dash is everything that doesn't belong to C. So what are all the everything that doesn't belong to C? It's the outside of the green circle. 1, 2, 7, and 8. So mark 1, 2, 7, and 8. Now what you need to do is you have to get the intersection of all of these. So what is the intersection? What's the region that's common to everyone? I think I can see region 1 is not common. Region 2 is there in all the 3. Okay, region 2 is common to all the 3. Is there anyone else? Region 3 is not common. Region 4, no. So the answer is region 2. So region 2, in region 2, how many shoes do we have? 0. So then probability will be 0. So 0 out of 120, basically 0. So probability of A intersection B intersection C dash is 0. Part C, find the probability of A union. Find the probability of A union, B union, C dash. Okay, so once again, either you can see we have the exact same set of people, right? So basically, what does it mean? In union, do we leave anyone outside? Do we leave anyone? No, we take every single person into account. So I have written the list here. So take every single region I have mentioned here. So what are the regions that we need to take? Region 1, then Region 2, region 3, region 4. Who else? 1, 2, 3, 4. Here I have 2, 3. I have taken here 6 and 7. Who else? 6 and 7. Here also 1, 2, 7. There's 8. So take everyone, regardless whether it's common or not. Everyone comes. So 1, 2, 3, 4, 6, 7, 8. Basically, everyone is there except 5. Can you see every region is covered here except region number 5. So do I need to like add all this? If you want, you can add everything in 1, 2, 1, 2, 3, 4, 6, 7, 8, and then write out of 120. Or the only region that's not here is region number 5, which is in region number 5 you have 7 elements. So what can I do to find that easily? From 120 total, I can subtract the elements in region 5, which is 7, and then divide by 120 because to get the total probability. So how much is it? 113 over 120. 113 over 120. Next one, part D. Find the probability that the shoe has at most one type of defect. Okay, what do you mean by at most one type of defect? So at most means maximum. Okay, maximum, it can have one type of defect. The word at most, you need to understand the meaning of at most. At most means the maximum is 1. So then can we, so it has at most one defect, or it can also have one. No defects. The meaning of at most means maximum is 1. It can even be 0, meaning 0 means there are no defects at all. So you have to understand the meaning of the word at most. If they say at least one defect, that means 1 or more. At most means 1 or less. Okay, at most 1 means 1 or less. What do you mean by less? The less is 1 or less means it's 0 defects. Okay, 1 defect or 0 defects. So what are the regions where I have 1 defect or where I have 0 defects? Region number 1 has only 1 defect, because then here region number 1 you have only defective stitching. Isn't it? Because if the because every place where the circles intersect, you get 2 or more defects where the circles intersect, right? Because each circle represents a defect. Another region that has only 1 defect is region number 7. Okay, this one has only 1 defect, B, only B, only defective coloring. Another one, region number 5, only defective soles. Is that all? Or less? 1 or less means no defects at all. Which one? Region 8 has no defects at all. Okay, so add all those and write the probability, right? So how many are there in region 1? We have 9. In region 5, I have 7. In region 7, I have 1. And in region 8, I have 93. How much is that? I add all these. It's 110, right? So probability of at most one defect. At most one defect is 110 out of 120, which gives us how much? 11 over 12. Okay. Then let's move on to part E. Given that, okay, given, the word given is there. So I think the moment you see it, you realize you have what probability? Conditional probability. A given B. Okay, given the selected shoe has at most one type of defect, find the probability. The finding probability part should come to the beginning of the given. Find the probability it has defective stitching. So if I write this, you need to find what? Find the probability it has defective stitching. So defective stitching is actually, I don't need to write it. Defective stitching is which type? Defective stitching is type A, right? So defective stitching means I need to find type A. So probability of A, defective stitching, given that what? Given that the selected shoe has at most one type of defect. The given shoe has at most one type of defect. Okay, so you can do this by using either you can think and do it, or you can use the equation and do. Thinking and doing means at most one means you only take the regions that consist of the at most one regions, right? So at most one regions fall to what? This set, right? For at most one we have only 110 out of 110. Do you get me? So I'll do it in the manual way, then I'll show you the equation way also. So at most one, the given that is the base of our probability. So at most one we have 110 shoes. So out of the at most one region, I think you can see I have marked them with a tick sign here. These are the regions where I have at most one defect. So out of those regions, where do I have A? Where do I have the intersection with at most one and A? Which region? Region 1, right? In at most 1, I have region 1, region 5, region 7, and region 8. So out of that, out of all those regions that I have picked, which one has a connection with A? Which one has a relationship with A? Region 1. So in region 1, we have 9. So basically, it's 9 out of 110 if you do the shortcut, the method, the short method. Or else, we can use the formula. What's the formula? Probability of A given at most 1. So how does that work? Probability A intersection at most 1. A intersection at most 1 over probability of at most 1. It's the same thing. Probability of at most 1 we found. What was the probability of at most 1? 11 out of 12. A given A intersection at most 1 is what? A intersection at most 1 is out of from the A circle. Where do you have at most 1? At most 1 defect is where? In region number 1. Do you get what I'm saying? So in region number 1, we have 9. So to make it a probability, you should write what? 9 out of 120. Type this in the calculation. You should get 9 over 110. 9 over 120 divided by 11 over 12. And we get 9 over 110 again. Do you see? So regardless which way you use, you should be able to get the answer. Next part, the random variable X is the number of the events A, B, C that occur for a randomly selected shoe. Find EX. Read the question again. Do you understand? The random variable X is what? The number of the events A, B, C. What do you mean by the number of the events A, B, C? Who are A, B, C? A, B, C represents the defects, right? So the number of the A, B, C means what? The number of the defects. We read this again. The random variable X is the number of the events A, B, C. So what are the events A, B, C? The events A, B, C represents the defects in the shoes, right? Okay, so the number means what? So number means you have to count 1, 2, 3, 4. Or maybe we can start with the so number of events. Or if number of events is 1, what does it mean? Number of events is 1 means A, B, C are the defects. So event is 1 means number of events is 1 means you have 1 defect. Number of events is 2 means we have 2 defects. 3 means 3 defects. Okay, they are asking you to find EX. Basically, how do you find EX? You make a table, right? To find EX, normally we make a table. So look how to make the table. So what are the X values we have? So X is the number of defects. So we can start with X value what? The number of defects can be what? Starting with the number of defects. 0. There are 0 defects. In how many shoes? Probability of 0 defects. Can I have how many shoes have 0 defects? 93. So probability of 0 defects is 93 over 120. Make this table. Next one, 1 defect. How many shoes have exactly 1 defect? Which regions do we talk about? 1 defect means only A or only B or only C. Which regions are they? 9. The region number 1 has only defect A. Then region number 5 has only defect C. Are you with me? And region number 7 has only defect B. Altogether, how much do we have? How much? 17. So 17 out of 120 for 1 defect. The next one, X is 2. How much? When X is 2. When X is 2, for X is 2 is there are 2 types of defects. What are the regions where you have 2 types of defects? Region number 4, yeah, region number 2, region number 2, region number 4, and region number 6. Because there you have the intersection where you have only 2 types. Only 2 circles are intersecting at that point. So region number 2, region number 4, region number 6. So how many are there? Count 5, 6, 7, 8, right? 8 and 0. So 8 out of 120. Do you understand? I add the values in these 3 regions. And the last one, what's the maximum number of defects we have? The maximum number of defects we have is 3. We don't have 4 defects, right? This shoe has only 3 types of defects they've given. So can I know the value? How many shoes have all the 3 types of defects? 2. So 2 out of 120. First thing is that you build this probability table. Now you can find what? EX. So how do we find EX? Ex is what? You multiply the x with the probability of x. So x is 0, multiply with the probability 93 over 120. Plus 1 times 17 over 120. Plus 2 times 8 over 120. Plus 3 times 2 over 120. Are you okay with this? This is okay? So what do we have here? Can you all simplify? How much is the answer? Type everything in the calc. 0 into 93 over 120 is just a 0. 1 into 17 over 120. Plus 2 times 8 over 120. Plus 3 times 2 over 120. How much do we get? 13 over 40. Is that okay? Do you get the answer 13 over 40? Yes. Question number 2. Tom's car holds 50 liters of petrol when the fuel tank is full. For each of 10 journeys, each starting with 50 liters of petrol in the fuel tank, Tom records the distance traveled d kilometers and the amount of petrol used p liters. Okay, so for how many journeys are we doing this? For 10 journeys, which means you have to understand what does the 10 represent? 10 represents because he's finding, he's recording the amount of petrol used for each journey. So then he's doing this 10 times, which means your end value is 10, right? The summary statistics for the 10 journeys are given below. Summation D, this is the amount of kilometers traveled, right? So they have given you the summary statistics. Calculate the product moment correlation coefficient between D and P. So that is simply the R value. Okay, how do we find the R value normally? So you are used to doing this with the SXY, SXX equation, right? So normally we write R equals to what? SXY over root SXX into SYY. However, now we don't have XY, we have the two values, who are they? D and P. Okay. So first thing here is you need to identify who is your dependent and independent variable. The variables we have are the distance travel and the amount of petrol used. So who is the dependent variable and who is the independent? So obviously the distance travel and the amount of petrol used is depending on the distance that you travel, which means the amount of petrol used is your dependent variable, the y variable, and the distance traveled is your independent variable or the x variable. Okay, so then here R equal SXY or SDP over root SXX is SDD into SPP. So you can see here SDD and SPP are given. All I have to do is I have to find SDP to find the value of my R. Okay, how do I find SPP? What's the equation for SXY? SXY, though it's given in the formula book as well. SXY is sigma XY minus sigma X sigma Y over N, right? You need to remember the formula. It's given in the formula book as well. So you have to convert the XY equation to DP. Just change the letter. Simple as that. Change the letter. XY sigma XY minus sigma X sigma Y over N. So SDP is sigma DP, right? Minus sigma D into sigma P over N. Is this okay? Check the equation. Okay, so then let's input the values here. Sigma dp is 5240.8, it's given. Minus sigma d is 1029 into sigma p is 50.8. Divide by n is 10. Can I know the value here? The exact 13.4 is the exact value, right? Check the answer. Okay, so then let's calculate the R value. R equals, so I have written the equation, right? SDP. So SDP is 13.48 divided by root SDD is 344.9 into SPP 0.576. Can you all calculate the answer? 95, tell me a little bit extra decimals. 956 383 4526. It goes on. Eh? Okay, then you can leave your answer to 3SS at the end. 0.956. Answers which round 0.956 are okay. Move on to part B. The amount of petrol remaining in the fuel tank for each journey, W liters. Okay, now who is W? They are introducing a new person called W. So who is W? W is the amount of the petrol remaining. Okay, what was our earlier variable that we used? The earlier variable we used was P. P is the amount of petrol that we used. So W is the amount of petrol that's remaining. Write down an equation for W in terms of P. It's that difficult. Now they say every journey when you start, when Tom starts the journey, every journey he starts with a full with 50 liters of petrol. Every journey, yeah, they say here. Each starting for each of 10 journeys, each starting with 50 liters of petrol. The journey, every journey before he starts, he makes sure he has 10 liters of petrol. So then, if W is the number is the liters of fuel that's remaining, how do you represent W? W equals 50 minus P. Right? Because 50 liters is what you have. P is the amount that you consume, the amount that you use. So then from the amount we had at the beginning, if you subtract the amount that you use, you can get the amount that is remaining. The remaining fuel in the tank. Do you agree? It's just a simple thing. Hence, write down the value of the product moment correlation between W and P. Okay, so this is basically what they are telling here, that P is actually, W equals 50 minus P is something like coding, right? You remember coding and product moment correlation coefficient? So what's the rule? Product moment correlation coefficient is affected or not affected? Product moment, no, they are asking here in part C, right? Write down the value of the product moment correlation between D and W. Okay. No, in part 2, they are asking you, hence, write down the value of the product moment correlation coefficient between W and P. Okay. They are asking you the coefficient between W and P. Okay, think about the correlation between W and P. We should be very careful here. One mistake we do is we always tend to think we immediately for 1 mark. Now we can feel this is 1 mark, so we tend to write this 0.956 for the answer for part 2 also. But however, when you see part C, we have another product moment correlation coefficient that they ask us. So be careful here. Now, what does R represent? R represents how closely the points are fitting to a straight line, right? Now here in the earlier part, we found the R value for what? The amount of the distance traveled and the petrol consumed, right? The distance travel and the petrol consumed. So that comes probably in a scatter plot. So then the points are lying close to a straight line. That's why you get a 0.956. However, in part 2, look what they're asking you to find. They are asking you to find the product moment correlation for what? For W and P. So W is the remaining fuel. P is the fuel that's used. The used fuel and the remaining fuel. So what do you think about these two? I mean, you can see directly, this is directly in a straight line equation. Can you see? W equals 50 minus P is directly in a straight line equation, right? So the amount of petrol used and the remaining petrol. What do you think when I plot this W and P values? Do you think I will get plots values that are scattering all over, or do you think I'll get points that are directly fitting onto a line? Do you see that it will directly fit? I mean, I directly have an equation here for W and P. It's already a straight line. Already a straight line with what gradient? Positive gradient or negative gradient? Can you see I have minus P? So it's a negative gradient. Okay? No. The product moment correlation between W and P, because product moment correlation values all come in between -1 and +1. Okay? No, R value is a coefficient. R value is not given in terms of anyone. R value is a coefficient that is given, that is in between -1 and +1. If R value is +1, your points fit to a perfect straight line. R value equal 1 means points are on a perfect straight line. All the points fit onto a straight line. If R value is -1, it means all the points are fitting to a perfect negative gradient straight line. If your R value is close to 0, it means the points don't fit at all. Points are all over the place. There is no fit. There is no fit. There is no pattern for the straight line. Okay, so here now what we need to do here is R value means how closely your points are fitting to a straight line. It doesn't come in terms of P or W. There's no such thing here. So they are asking the product moment correlation coefficient. between W and P. So you can see W and P are anyway, we can see we have written a straight line connecting W and P, the used petrol and the remaining petrol. And you can see this is a line that has a negative gradient. A negative gradient means the line goes in this manner, which means what? Which means what? Your R values are, I mean, you are having a negative gradient and the straight line, all the points are going to fit perfectly. So which means what? Your R value should be what? -1. So the product moment correlation coefficient between W and P is -1. Okay, so that is the important, that's the tricky part here. Part C. Yeah, if the equation is, because this equation is given only, I was able to identify it's -1 because this is directly fitting onto a straight line. When it directly fits onto a straight line, then R values are going to be 1 or -1. 1 for positive gradient, -1 for negative gradient. Then write down the value of the product moment correlation coefficient between D and W. So what do you mean D and W? Now again, D is what? Do we have D and W in a perfect straight line? Because you can see D is the distance travel. Again, W is the petrol that's remaining. Earlier we had the coefficient between what? D and P, right? This R value we found was for D and P. So now we want the R value for D and W. So what do you think about this? Now you can see here, W is what we, W is something like a coding that we use instead of P, right? You remember coding? So W is like the coding, I mean W is written as 50 minus P. So W is the variable we can write instead of P by doing a simple coding here. So then what happens? D and W. So basically, you know, the product moment correlation coefficient, okay, the P value here is coded. Okay, by using 50 minus P and we get W. So basically, when you do D and P, we got 0.956. So when we go for D and W now, so product moment correlation coefficient is not affected by coding. It is not affected, which means the RDW should be 0.956 because this is between distance and the amount of petrol that's remaining. The amount of petrol that's remaining is like a coding because it's 50 minus P, 50 minus the amount of petrol that's used. This is like a coding that we use. So therefore, when you come to this, these RDP and RDW are the same because basically P has been coded by using W. So product moment correlation coefficient is not affected by coding. Therefore, the answer for RDP and RDW does not change. Oh, there's one more thing, however. There's one extra thing. Sorry. The thing doesn't change, but there's one extra thing. What is it? When it comes to P, P was the amount of petrol that's used. And W is the amount of petrol that's remaining, right? Then there's one more thing here, children. Can you all guess what it is? It's negative. Because the earlier we had a positive correlation for the amount of petrol that we use and the amount of petrol that we use and the distance travel. So now we have the same thing for the distance travel and the amount of petrol that's remaining. So you have the exact same coefficient, but now it's going to go the other way. So it's going to be negative. That's the only thing. The value is exactly the same, but the sign is different. Okay, so just be careful. You need to read the question and you have to understand and you have to write the answer. Okay. You can think of it like this. Now you understand here in this case, the R value being positive is understandable. Why? Positive R value means when one variable increases, the other one also increases, right? Positive R value means, so now in this case, when the distance increases, the amount of petrol that's used is also increasing, right? Do you agree? RDP, when you see this kind of a positive reading means the scatter plot goes like this. Basically, when the distance increases, the petrol usage increases. That's common sense. Now, in this graph, it's the distance against W. So when you say distance against W, W is the petrol that's remaining. So then when the amount of distance you travel increases, what happens to the petrol that's remaining? Is it increasing? Will the points increase or will the points decrease? The points will go down, right? Because the more you travel, the higher the distance you travel, the higher the distance you travel, the petrol amount that's remaining will go down. And you can clearly see it's negative gradient. Therefore, your R value should be negative. Okay, R value says you the relationship between the two variables. If both are increasing simultaneously, R is positive. If one increases and the other decreases, that's a negative. So here definitely when the distance increases, the amount of petrol that's remaining will decrease. The amount of petrol that's remaining will decrease. The more you travel, the more you use. Therefore, the less is remaining. So the more I go to this side, you can see these points have a low amount of petrol remaining. Understood? So it's clearly a negative gradient. So when your graph goes like this, definitely R value is negative. And then make sure, because it's the same variable. I mean, it's a coding that we have used here. The value for the R coefficient, the correlation coefficient value will not change. Okay, I hope this is clear with all of you now. Generally, coding doesn't affect the product moment correlation coefficient. However, the thing is, we have here 50 minus B. Now, if this was P minus 50, then it wouldn't affect. Actually, the value won't change at all. Okay, the problem here is it's not 50 plus P or it's not P plus P minus 50. It's a minus P here, meaning your variable itself has been, they have made it negative. So when your variable itself has been converted to a negative value, so in this case, the coding you need to be careful, because the coding that we generally use is we use P plus 10, we use 2P plus, I mean, we don't make the variable negative generally in what we do in the S1 book. We don't go like that. But in here, the variable itself has been, they turn it to the negative value of it. Okay, so you can think of it in real life context and then it makes sense. Okay. This one, W is equal to 50 minus P, this equation, because from this equation, I realized that we are doing a coding here. However, the only thing is the variable, the original variable has been totally converted to negative. Okay, so from that I realize, okay, it's kind of a coding here. The value is definitely not changing the value, but the signs will definitely change. The graph also, by thinking about these graphs, also it helps you to realize this is positive and this is definitely negative. Okay. Okay, we'll move on to question number 3. The stem and leaf diagram shows the number of deliveries made by Pat each day for 24 days. Okay. So the key, now it's very important that you read and understand the key. So here 10 and the 8 represents 108 deliveries. Do you see? So 10 and here the stem is 10, the leaf is 8. So it's 108. 10, stem is 10, leaf is 9, it's 109. Can you see? So you can see most of the stem and leaf diagram is not complete, because you can see some values are unknown. So you see that we have here A, B, C values which are unknown. Here where A, B, C are positive integers with A less than B, who is less than C. So this A, B, C is in order, ascending order. C is the largest and A is the smallest. And outlier is defined as any value greater than 1.5 times the interquartile range above the upper quartile. Okay, so you know about these limits, right? These we always have two limits, where the two limits, if you jump the upper limit, then you have it's an outlier. If you are having a value less than the lower limit, it's also an outlier. So they have told you an outlier is any value greater than 1.5 times IQR. Given that there is only one outlier for this data, so they are saying for this entire data set, there is only one outlier. Show that C becomes equal to 9. Okay, how do I show that? First things first, anyway, we have to do what? We have to first find the lower quartile, the upper quartile, and get the interquartile range. Shall we do that? So how do we find lower quartile, upper quartile? How many data points do we have here? Add everything. 24, right? So let's get the equation for the lower quartile, the upper quartile and the lower quartile. So part A, Q1. So what is Q1? Q1 is, what's the equation we use? N divided by 4, right? So N is 24 divided by 4, which is? N divided by 4. We use N over 4. No. Okay. We use N over 4. So 24 divided by 4, we get 6. So what's the rule? If you get a whole number in discrete data, we use N over 4, this equation. If you get a whole number, take the midpoint of that term and the term above. Well, if you get a decimal answer, the book says us to round the number up. So here I get a whole answer, which means Q1 is the sixth term plus the seventh term. You add and divide by 2. That's the rule that you learn in the S1 book. So what's our sixth term and seventh term? This is in order, right? 1, 2, 3, 4, 5, 6 term and 7 term are both what? 116. Do you see? It's 116. Both of them are 116. So lower quartile is 116. Do you agree with that? Upper quartile, let's find Q3. 3n over 4. So 3 times 24 divided by 4 is how much? We get here the 18th term, right? Am I correct? We get the 18th term. So 18th term is, not only the 18, we take 18th plus the 19th term and divide by 2. Are you okay with that? So go to the 18th and 19th question. So here I have 11, 2 terms. Here I have 11. So 11 plus 2, there are 13 terms here. So then 14, 15, 16, 17. So this one is the 18th and this one is the 19th. So 18th term, 19th term are both 125. Do you agree with me? So then nothing to, since both are 125, your Q3 will be 125. Is that okay? So shall we find the upper fence for the quartile? So what's the upper limit or the upper fence? They say it's 1.5 times IQR above the upper quartile. So Q3 plus 1.5 times IQR. Can I know the limit here? Q3 is 125 plus 1.5 times interquartile range is 125 minus 116. What's the answer that we get here? 138.5. 138.5. Okay. So now they are saying to you that there is only one outlier. When they say there is only one outlier, and they say now they say very clearly outlier is at the top end, not at the bottom end. They say clearly we are looking at the upper limit also here. So when there is an outlier, if there's only one outlier, who should that outlier be? Can it be this A? No, it has to be this C here, right? It has to be the C here because C is the biggest value. From all of them, from all this data set, this data set is fully arranged. This C here, along with the 130 and something with the C, this I don't know what it is, but this last value has to be the outlier because it's the biggest value. And the upper limit is 138.5. So if the upper limit is 138.5, then anything that jumps that is an outlier. So then what can I have for C here? 139. Can I go for 140? 141? No, because the stem doesn't agree. The stem is 13. We don't have 14 here. So I can't go for 140, 140 because the rule is anything that is jumping above 138.5 is an outlier. So that means I can go for 139, 137, 140, anything above. But the thing is my stem here is 13, 13. So it has to be with something with 130. So the only number that I have that is jumping 138.5 is 139. So you understand? So C value must be 9. So you can write here outlier. Outlier is 139. Therefore, C equal 9. Do you understand? Your outlier is 139. Therefore, C should be 9. Okay, then let's move to the next one. The number of deliveries made by Pat each day is represented by D. Okay, so the number of deliveries. So the number of deliveries only they have made by Pat each day for 24 days is what they have given here. Okay, the number of deliveries made by Pat each day is represented by D. The data in the stem and leaf diagram are coded using X equal D minus 125. Now you know the data in the stem and leaf diagram gives you the number of deliveries made by Pat. Right, each day. For how many days? For 24 days. So you have 24 data points, and this shows you how many deliveries this person has made per day. Now they are saying to use the coding X equal D minus 125. So D values represent these values over here. Then they say, and the following summary statistics are obtained. Summation of X is minus 96. Summation X minus X bar square is 1306. Find the mean number of deliveries. Okay. So how do we find the mean number of deliveries? What's the equation for the mean? So mean is equal to what's the equation? Sigma X over N. This is the equation we learned in chapter 2. Mean equals sigma x over n. Do we know the sigma x value? Yes, minus 96 over what's our n value? 24. Can I know the answer? Minus 96 divided by 24? Minus 4. Simple as that. Minus 4. Find the standard deviation. Okay, so this is the place where you need to think a little bit. Okay. Yeah, so here we have found the mean for the coded data, right? Yeah, so the question says you to what? Find the mean number of deliveries. So mean number of deliveries, X is not representing at the delivery, X is just the coding that we apply on the deliveries. Do you realize? So to find the X bar, what do we need to do? So this mean that I found here is the D bar. So basically the D bar value is minus 4. I have to find X bar. So go to take the equation and you know the mean is affected by coding. So what do you get here? I can rewrite the equation X bar equal D bar minus 125. Okay, so I had to find the mean. I had to find the, this what I have found here is the X bar. Okay, because we found the mean for X data while our real data set is in D. So the X bar value is minus 4. I want to find the mean for the deliveries, D bar. So minus 4 plus 125 gives me the D bar. How much is the mean number of deliveries? Minus 4 plus 125 is 121. So the mean number of deliveries is 121. Is that clear? This is using coding. Okay, so now to find the standard deviation of the number of deliveries, so you can see the formula they have given is x minus x bar square. So actually I was writing a few equations here for your reference. So these are the equations you need to know to survive this, right? So basically mainly the equation that we use is this guy, sigma x square over n minus sigma x over n whole thing square. But in addition to that, you must also know these two equations for the standard deviation. Sigma x minus x bar square over n and sxx over n. Really important because there are places where you definitely need to know this equation to survive. Okay. These are also other equation plus the variance is the squaring of this. So when I write variance is the square of this. So all these equations, if you remove the root, you end up getting the variance. Okay. Right. Now I want to find the standard deviation of the number of deliveries. So you can see I can use the second equation. Can you see? Because sigma x minus x bar square is given to you as 1306. So if you divide that with your n and root it, you can get the standard deviation of what? You will end up getting the standard deviation of x. Okay. However, you are not done yet because the question asks you to find what? The standard deviation for the number of deliveries. Okay. So let's get it done first. Part C. So standard deviation will be sigma x minus x bar square is 1306. So the square itself is given. Okay, that's 1306 divided by n is 24, right? We have 24 here. Circle it and root of it. How much is the standard deviation? Can I know the answer? 4 point. No. 7.37677. Okay, right. So, and then what you do is now you get here the standard deviation of what? This is sigma x. This is sigma x. Now, what do we need to find? We have to find the standard deviation. Standard deviation, we use this sigma notation. They are asking you to find the standard deviation for the number of deliveries, sigma d. So again, this is something you have learned in the chapter 2 coding. So the coding equation we use x equal d minus 125. So when you convert to sigma, do you remember what was the rule in standard deviation? Standard deviation is not affected by adding or subtracting. When you do coding, adding, subtracting doesn't affect the standard deviation. Only multiply and dividing this. So basically, when you convert to sigma x, sigma x becomes what? Sigma d, the minus 125 doesn't apply. But when you are doing the mean, I think you saw for mean everything applied. X bar x equal d minus 125. This became x bar equal d bar minus 125. Adding, subtracting, multiply, dividing, everything affects the mean. However, when it comes to standard deviation, it's not affected by adding or subtracting. So sigma x equals sigma d, the minus 125 doesn't come for the coding, doesn't come for the standard deviation, which means what? What's the standard deviation for the deliveries? Standard deviation for the number of deliveries is 7.37. 7.377 or 7.38. Do you agree with me? So this is the answer. Then let's go to the next one. One of these 24 days is selected at random. The random variable D represents the number of deliveries made by Pat on this day. Okay, then the random variable X equals to D minus 125. Find the probability that D is greater than 118 given that X is less than 0. So, okay, so given that, first thing is that when you have a given that, your probability is taken entirely from only the given that part. Okay, so first shall we find the set of D values that makes X less than 0. First find that. Now do we have X less than? So X less than 0. Now what do we know about X? First we'll find this given that. What do we know when X is less than 0? We know X is equal to what? D minus 125, right? X is D minus 125. So this is D minus 125 is less than 0, which means what? D is less than plus 125. Do you agree with me? Do you agree with me? Which means this sum I can rewrite it. So now instead of writing with two variables D and X, I can rewrite both with respect to D. Okay? Yes, X is the quadrant one, D is the original one. So when they give you X less than 0, I can't work with both these data. I converted the X to D. Now rewrite the sum again. Probability D is greater than 118 given that X is less than 0. Sorry, not X is less than 0. We are going to work with D. D is less than 125. So you remember how to work with a given that? In given that's how do we work? On top, now if I use the formula, it's easy to use the formula here. On the top, what should you write? When you open the given that, on top, what do we write? This is A given B. A given B. On top, you write probability A intersection B over probability of D. Are you all with me? So this is probability. Intersection is what? D greater than 118 intersection D less than 125 over probability that what? D is less than 125. Are you with me? Okay, so then let's get the answers here. How do I find the probability? Now here, I want all the distances where D is more than 180, but it should be less than 125. How many such deliveries do we have? How many such data points do we have where the deliveries are more than 118? Number of deliveries are more than 118 and less than 125. What's the probability? Find all those more than 118, less than 125. So all of these, right? More than 118 means we have take 119, 119, 119 and less than 124. So 124, these guys, right? There are only 5 days. There are only 5 days where the deliveries are between 118 and 125. More than 118 and less than 125. There are only 5 days. Do you agree? Okay, and so that is the answer that I have right on top. So for this one, the probability is you have 5 days out of how many days? 5 days out of 24, your deliveries were in this particular range. Are you with me? Now find here the probability that your deliveries are less than 125. In which days are the deliveries less than 125? How many days? Deliveries are less than 125 means everything that comes in here, right? All of these that are underlined in green are less than 125. Do you agree with me? How many data points are there for these two? This is 2 plus 11, 13 data points from the first two rows. And with this one, it's 14. So there are 14 data points here. So 14 days. So 14 out of 24. Okay, so 5 over 24 divided by 14 over 24, which gives you 5 over 14. So 5 over 14 is the probability that your deliveries are in this given range. Okay, question number 4, the random variable W has a discrete uniform distribution. So you remember what are discrete uniform distribution? In discrete uniform distribution, every single X value has what? every single x value has the exact same probability. That's why we use the word discrete uniform distribution. Every single x value, I mean here it's not Excel, it's W value. So can you make the table? If you make the table, you don't need the table. I'm going to answer part A. However, part at the table, I mean, basically what you have here, the W values are 1, 2, 3, 4, and 5. So probability that W equals simple W is what? Each and every W value has what? The exact same probability. Every single W value has the exact same probability. So how much is it? 1 for 1, it's 1 over 5. For 2 also, it's 1 over 5. For 3 also, it's 1 over 5. 4 also, it's 1 over 5. For 5 also, it's 1 over 5. Okay? Right. Then they are asking you find the probability that W is greater than or equal to less than 3.5. So what are the W values? Now you know this is discrete. Do we have decimal figures? No, you have 2, 3, 4, 5. That's it. 1, 2, 3, 4, 5. That's it, and no figures in between. So when they say a W is greater than or equal to, what are the W values we include? We can include W2 and who else? W3. Can I go for W equals 4? No, right? So W equals 3 we can include because it's less than 3.5, but I can't go for 4. And there's no value called 3.5. Are you with me? In this table, there's no value called 3.5. Okay, because the x values are given here 1, 2, 3, 4, 5. Okay, then what do we do here? So probability W equal to is 1 over 5. Probability W equal 3 is 1 over 5. Answer is 2 over 5. Are you with me? Part B, they say the discrete random variable x is 5 minus 2W. Again, coding. Find Ex. Okay, so how do we find Ex? I recommend you to first find what? EW. First find EW. How do you find EW? It's a discrete uniform distribution. Is it very difficult to find the EW? It's a discrete uniform distribution. All the probability values are the same. Your mean should come exactly where? The mean W value should come exactly in the middle, or you can use the equation if your W values are in the form 1, 2, 3, 4. They have given you in the book. We can use n plus 1 over 2. This is a formula given in the book. As long as you have for your W values or the X values here, you should have 1, 2, 3, 4, 5, 6, 7 in order. Okay, and if it's discrete uniform, as long as it's a discrete uniform distribution where your values are going with starting with the counting numbers, then you can use this equation. Otherwise, you can use the normal equation we use. We multiply the x value with the probability and we add and do. So you could do that. However, we don't need to do that. You don't even need this equation. If you realize that this is a symmetric distribution, everyone has the exact same probability. These values are in order, so the mean should come to the exact middle W value. The mean should come to the exact middle W value. That's all. Or else n plus 1. This is 5 plus 1 over 2. 5 plus 1 is 6. 6 divided by 2 is what? 3. So your EW value is 3. Do you get what I'm talking to you about? Okay, so you can directly write EW is direct. By observation, you can write EW is 3. Now, how do I get expectation of X? Expectation of X is what? Expectation of 5 minus 2W. Let's get this. Expectation of 5 is 5 minus 2 times expectation of W. So 5 minus 2 times expectation of W is 3. So 5 minus 2 times 3 is 6. What's the answer? Minus 1. The answer is minus 1. Okay, then part C. They ask you to find the probability that X is less than W. How do I find the probability X is less than W? Part C, find the probability that X is less than W. How do we do this? So then probability X is less than W. The easiest way to do it is, I don't want you to input the W value, X value individually and think which X value is less than the respective W value. No. What you do here is they have told you what is X. Here X is given as what? 5 minus 2W, right? X is given as 5 minus 2W. Go to the equation and replace the X with what? 5 minus 2w. Do you see what I did here? I replace my x here with 5 minus 2w. And now can't you make w the subject? 5 minus 2w goes to the side as plus 2w. W plus 2w is 3w. So I end up getting here w greater than 5 over 3. Can you see if I write to the correct side, w, the mouth is open towards w and 5 over 3. So who is 5 over 3? What do you mean by 5 over 3? A value of something in 1 point range, right? 5 over 3 is exactly how much is it? 1.666, something like that, right? So w value is greater than 1.66. So who are the values that are greater than 1.66? What are the w values greater than 1.66? Tell me, look at the table. 2, 3, 4, and 5. So add all the probabilities. Basically, w greater than 5 over 3 includes w2, basically w3, w4, w5, w5. So basically w greater than or equal to everything. All of these guys are coming. So 1 over 5 into 1 over 5, I mean, not into, adding. So when you add 1 over 5 4 times, what do we get? Directly, it's 4 over 5. Do you understand? This is the easiest way to do it. Okay. The next one, the random variable y equal 1 over w. Find the probability distribution of y. What do you mean by the probability distribution? The probability distribution means you have to make the table. Okay, make the table. Now I wrote the probability distribution of w. Likewise, make the table for y here. So what are the y values? Y values are 1 over w, right? So tell me what are the values? 1 over w. So first w value is 1. So 1 over 1 is 1, right? Next w value is 2. So 1 over w gives you what? Half. The next y value is half. Are you with me? Next y value. When w is 3, y value becomes 1 over 3. When w is 4, y becomes 1 over 4. When w is 5, y becomes 1 over 5. And then the probability that y, do you think the probabilities are changing? Just because we use the change the variable value, the probability of occurring this w variable doesn't change. Okay, because when w is 1, the respective y value is 1. The probability of getting w equal 1 doesn't change. Okay, so all these probabilities are remaining constant. So this is my what? This is my probability distribution. So this is my probability distribution for y. Okay, this is my probability distribution for y. Okay, then Roman number 2, variance y, showing your working. So I think you can see there is a large amount of, we have a large amount of marks here to find variance y. So we can't use any equations that we have. A plus bx variance, a plus bx doesn't work because it's not a linear transformation. So y 1 over w, you'll have to find this manually, meaning you'll find the expectation y. Okay, what is expectation y? Do I again have to work really hard to find ey? You can see all the probabilities are the same. So ey has definitely, okay, what we'll do like this. Yeah. Shall we multiply and find ey? Yeah, so here we can't use any shortcuts. The reason being the gap between the y values, are they the same? No, the gap between 1.5, the gap between half and 1 over third. So these gaps are all different. So I can't take the middle value because the probabilities are distributed equally. I can't take the middle value as the mean because these y values are not distributed equally. Okay, so we'll have to find ey definitely by what? By doing the manual technique. What's the manual method? Multiply the y value with its respective probability. So what's the first one? 1 you multiply with 1 over 5 plus the next one is half you multiply with 1 over 5 plus the next one 1 over 3 you multiply with 1 over 5 plus the next one 1 over 4 you multiply with 1 over 5 plus the last one 1 over 5 you multiply with 1 over 5. Can I know the answer? 137 over 300 is your EY. So to find variance y, what is the next thing I need to find? I have to find EY square. EY square means you square the y value and multiply with the probability. So what's our y value? 1. So 1 square into 1 over 5. Next one, half square into 1 over 5. Next y value is 1 over 3 square into 1 over 5. Next one, 1 over 4 square into 1 over 5. Next one, 1 over 5 square into 1 over 5. Can I have the answer? It's 5,269 over. No. Check again. 5,269 is good. Let's work on this. 1 into 1 over 5 plus half square is 1 over 4 into 1 over 5 plus 1 over 3 square is 1 over 9 into 1 over 5 plus 1 over 4 square is 1 over 16 into 1 over 5 plus 1 over 5 square is 1 over 25 into 1 over 5. So I get 5,269 over 18,000. And you see I get this over 18,000. Okay, then we'll find variance y. So variance y is EY square minus EY whole thing square. EY square minus EY whole thing square. EY square is 5,269 over 18,000 minus EY is 137 over 300 whole thing square. How much is it? How much is it? Simplify. I get 947 over 11,250. 0.084177. Is that okay? Which is 0.0842, right? - 0.084177, so 842. 3 SF answer. Okay, do you agree with my working? Next one, part E. Find the variance of 2 minus 3y. Okay, so for this one again, you have to remember the rules you learned in the S1 book. So basically in S1 we learned these two equations, E of AX plus B and variance of AX plus B. Do you remember these two rules? For expectation, we get A times EX plus B. This one we already used now a moment ago. The other equation for variance, do you remember how it opens? Variance AX plus B, how does the bracket open? A square YX, does the plus B come? The plus B doesn't come. So these are the rules you need to remember to survive this. So here basically variance 2 minus 3y, when I open the bracket, will the 2 come out? 2 is alone without the y. So 2 doesn't come out, 2 is, it just becomes a 0. Now minus 3, what happens? We need to square whatever the value is with our variable, right? So we get minus 3 what? Square times variance y. Minus 3 square is 9 times variance y was 947 over 11,250. How much is it? I get 947 over 1,250 or 0.7576. 0.7576. Okay, so this is it. This is the answer. I hope all of you are clear with this. Okay, question number 5. Gia writes a computer program that randomly generates values from a normal distribution. He sets the mean as 40 and the standard deviation as 2.4. Find the probability that a particular value generated by the computer program is less than 37. Okay, how do we find this? Here writes a computer program that randomly generates values from a normal distribution. He sets the mean as 40 and the standard deviation as 2.4. Okay, so then x is the value that's generated from the normal distribution, right? So x has a normal distribution with mean 40, standard deviation 2.4, means variance is 2.4 square, right? Find the probability that the particular value generated by the computer is less than 37, which means what? X is less than 37. Let's find this. So turn x to z, x minus mu over sigma. X minus mu over sigma, this one less than 37 minus mu is 40 over sigma is 2.4. So x minus mu over sigma is z. 37 minus 40 is 37 minus 40 divided by 2.4. Can I know the value? 37 minus 40 divided by 2.4 is minus 1.25. So is it less than minus 1.25? So I taught you all, I mean, we did how to find the probability, right? We learned how to find the probabilities. Is it less than minus 1.25? So this area, so we learned z less than minus 1.25 area is exactly the same as what? Z is greater than plus 1.25. Do you remember? And z greater than plus 1.25 area is equal to 1 minus probability z is less than 1.25. These are the equations we learned in normal distribution, right? So 1 minus, can I know the probability that is less than 1.25? You can find the probability from the calculator, or you can use the table. Can you all use the table and tell me the answer? From the normal distribution, z value 1.25. What's the probability? What's the phi z value? For 1.25, what's the phi z value? Check and let me know. Yeah, so phi z value for 1.25 is 0.8944. So answer 1 minus 0.8944 is 1 minus 0.8944 is how much? 0.106. Moving on to part B. GR changes the mean to M but leaves the standard deviation as 2.4. Okay, so we are going to a completely new variable. Okay, so now what happens? Now let's say variable Y has a normal distribution, mean is M, but the standard deviation is 2.4. That doesn't change. The computer program then randomly generates two independent values from this normal distribution. That the probability that both of these values are greater than 32 is 0.16. Find the value of M, giving your answer 2 decimal places. Okay, so there's a small thinking part here. Now, if they told you the probability that a value greater than the value, but the probability of a value greater than 32 is 0.16, you would have found it very easy to do. But now they are saying how many values here? They are saying the computer program generates how many independent values? Two independent values. The probability that both of them are greater than 32, which means what? Probability Y greater than 32 is for one variable. Both means what? There are two, I mean, we are taking two variables. So when you are taking another variable, is it into or a plus? The computer generates two variables. Both are, the probability that both are greater than 32 is 0.16. Imagine like a tree diagram. First value is greater than 32. Second value also greater than 32. What do you do along the branch? You multiply, right? So probability that both the values are greater than 32 is 0.16. Which means what? This is the square of the probability Y greater than 32, right? Probability Y greater than 32 square, which means what? If I want to find the value of Y greater than 32 a single digit, all I have to do is root 0.16, right? The square root of 0.16, because this is two values. Both the values are greater than 32 is 0.16. So both of them together means it's an and. We have to multiply. So then Y greater than 32 is the probability square. So to get the value of the single probability, we have to root the other side, which is what? Probability y greater than 32 is how much? 0.4. So now we can work with this. Now let's work with this. Turn y to z. So y minus mu over sigma. 32 minus mu is 2.4 over sigma is the sigma value is 32 minus mu is unknown m. Sigma is 2.4. Y minus mu over sigma is z. 32 minus m over 2.4. Let's say it's a p value something. Just use some variable here, 0.4. So z greater than p is 0.4. First thing is this, locate whether your p is positive or negative. Is this p positive or negative? You have a probability value 0.4 is less than 0.5. So a small area should be colored. So z greater than p. Let me input my p value over here. Is this p value correct? Z greater than p is this area. Can this area be a 0.4? Can, right? It's less than half. So this area can be a 0.4. And then when you look at this probability value, it's a very neat probability value. There are two probability tables given in your table. So use the second table. P is a positive figure. And then use the second table. The second 1 minus 5z table. Yes?
0.2533.
P is 0.2533. Check the second table. Okay, not the first normal table, the second normal table. Okay. Let me show it to you all. This is the table that I was talking about, the second table, 1 minus 5z table. This gives you the areas in front. So for 0.4, the z value is 0.2533. Do you see? Okay. Okay. So then now p value is not what we need. We have to find m. So what is p? I use p instead of 32 minus m over 2.4 equal to 0.2533. Get me the m value. 0.2533 times 2.4. So basically m equals to 32 minus, right? How much is m? M is 31.39. Can I have a few more figures? 31.39. 208. So 3 SF, your m value is 31.4. Okay, so this is the m value. Yeah, they want to find the value of m, giving you answer 2 decimals. Okay, they wanted to 2 decimals. So what's the find the value of m, giving your answer 2 decimal places. So what is the answer 2 decimals? 31.39, right? Okay, so this is the answer, 31.39 to 2 decimals. Okay, then let's go to the next part. Jihan now changes the mean to 4 and the standard deviation to 8. The computer program then randomly generates 5 independent values from this normal distribution. Find the probability that at least one of these values is negative. Okay. So let's do this one again. Let's take a different variable now. Don't use Z. It is standard normal. I'll use A. So A now has a normal distribution with mean 4. Standard deviation 8 means variance is 8 square. The computer program then randomly generates 5 independent values from this normal distribution. Find the probability at least one of these values is negative. Okay. Before we go for 5 values, let's work with one value. Okay. Find the probability one value is negative means what? Your A is what? Negative means your A value should be less than 0, right? So find the probability your A value is less than 0. How do you find that? Turn A to Z. How to turn A to Z? A minus mu over sigma. Less than 0 minus 4 over sigma is 8. A minus mu over sigma is Z. Minus 4 over 8 is minus 0.5, right? So get the answer. Probability Z less than minus half is equal to Z greater than plus half. These are rules. Z greater than plus half is 1 minus probability Z is less than 0.5. So we can use our table. This is all this is done so that we can use our table. So go to the table. use the first table. In the first table, we get the area behind. So the Z value we got was 0.5. What's the area? So 0.5, we get 0.6915, right? Can you see? 0.6915. So 1 minus 0.6915. Can I have the answer? Yeah, subtract. What is the answer?
1.3085.
0.3085. So this is the probability that a single value is negative, right? Now they are talking about how many values. They are saying that the computer program generates 5 independent values. Find the probability that at least one of the values is negative means what? At least one value is negative. Now this is the probability that one value is negative. Now you know you are generating 5 values. Okay, so so you are generating 5 values and you want the probability at least one of them is negative means what? Either one figure or 2 figures or 3 figures or 4 figures or all the 5 figures need to be negative. Are you with me? So either, I mean, you need to find, I mean, basically, so let's say, give a variable, let B. B is the number of negative values. B is the number of negative values. So what do we, how many negative values do we need? We need the probability we get, but at least one negative value means B can be 1. We get one negative value and 4 are not negative. Or you can get what? B is 2. B is 2 means you get 2 negative and 3 are not negative. Then like B equal 3, B equal 4, B equal 5, right? Okay, I'm explaining to you all. There's a shorter way to do this. So B is the number of negative values. So this is the probability of getting one negative value. 0.3085 is the probability that one value is negative. So if two values are negative, what happens? This is getting squared, right? Okay, now the thing is this. Okay, the thing is this. Don't go to work with this. Now you can see in here the only one that doesn't come is what? So for when we say B is the number of negative values and we want at least one value to be negative, we need all these probabilities. So the only one that we don't use is what? The one where everyone is positive. Look at this. The one where everyone is positive means the only probability that is not used here is the B equals 0, 1, right? Everything else is used. You know the total probability is 1. So if the total probability is 1, children, what you can do is to find the probability of at least one negative. From the total probability 1, you subtract the probability of getting 0 negative values. Everything is positive. Okay. Okay, so is this a little bit tough? If you go in this path, it's a lot more tough. This is the easiest way. In this path, you have to get here. This is if you go now, for example, if you say B equal 1, it means out of the 5 values, 1 is negative, the other 4 are negative, the other 4 are positive. If you go in this path, 2 values are negative and 3 values are positive. I mean, getting the probability is a little bit difficult here. Because you know you are not just multiplying. Now here you have to multiply all the now for example, just to tell you what is happening here. Say you want to find the probability B is 1, B equal 1 means what? From the 5 values, one is one is negative and the others are positive, right? Actually, I wouldn't even want you to do this part. Okay, if you go in this path, you have to even go for the arrangements also. Okay, I really don't want to go down that path. Basically, what you do is you just subtract the one that you don't need. From 1, subtract the only part you don't need. The only part you don't need is where B is 0 or you have 0 negative values, which means what? Every single value we get here is positive. But what's the probability of getting a positive figure? If A less than 0, probability is 0.3085. This is the probability of getting a negative figure. What's the probability of it being not negative? What's the probability of it being not negative? Non-negative. A greater than or equal 0. What's the probability of it being non-negative? 0.3085 is the probability it's negative. So do 1 minus. The other side, the remaining probability should be the positive probability. How much is it? 1 minus 0.3085 is how much? 0.6915. This is the probability that a single digit is what? This is the probability that a single digit is positive. Now, what do I want? B0 means All your 5 digits are positive. So if all the 5 digits are positive, what does it mean? 0.6915 times 5. Every single digit, the first digit is positive. Again, the second digit is positive, and the third digit is positive, and the fourth is positive, and the fifth is positive. So what do you need to do? It's a multiplication, right? First is positive, and second is positive, and third is positive. Likewise, it keep on multiplying, which means what? In other words, it's 0.6915 to the power 5. Because I want it continuously all the 5 figures to not to be positive. Positive probability of a single digit is 0.6915. So that again, and another next value is also positive. So 5 times all the 5 figures should be positive. So it's an and. It's like you continue along the same branch of the tree diagram. Positive, 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 positive. So all the branch, the entire thing we multiply the probability. So positive probability not into 5 to the power 5, because we need it to be an and. And means this after this, the next one is also positive, and next one also positive. It's like a single branch in a tree diagram. Okay, so how much is the answer? 1 minus 0.6915 to the power 5 is 0.84188, or basically have they asked you for 3 decimals or anything? No, right? 0.842. So this is a little bit tough here. You need to understand what's going on, but like definitely you have to travel in this path. Okay, you can't go in this path. It's way too much difficult. Go in this path because there are 5 figures. So at least one value is negative means what? At least one value is negative means the only part that doesn't come is where everyone is positive. Okay, so from 1 you subtract the probability where every single figure is positive, and then the remaining probability gives you the this is the probability that at least one figure is negative. Okay, I hope this is clear with you all. Please ask me questions if you have. Okay, so basically, again, just because I feel you guys are having a difficult time here, now they say to find the probability at least one of the values is negative. At least one of the values is negative is, for example, B is the number of negative values. So if B equal 1, it means there is one negative value. There's one negative value when all the other remaining 5 are what? So we'll say B negative, all the others are plus. All the others means the other 4. Okay, so then if you want to find the probability of B equal 1, this is just one path where B is 1. Okay, but then you can see you can have different arrangements for this. Like this B minus, the negative B value, you can have it anywhere. You can have it like in different arrangements. So B equal 2 means 2 values are negative, and the remaining 3 values are positive, or actually it can even be 0. Positive or 0. Okay, I'm just putting a notation here to explain to you why I'm not going like this. And then in here also, this is one part. These 2 negatives I can arrange. I have tried all the possible arrangements. And then I have to find the probability of one single path and multiply. Now, for example, what's the probability of this path? The probability of getting one negative is, the probability of one negative number is 0.3085 times what's the probability of a positive number? 0.6915. And since there are 4 positive numbers, it's to the power 4. That is the probability of this part for getting one negative, but this is not the only part. This can be arranged in, I think, we can arrange this in 5 ways. So then into 5, that would give you the probability B is 1. That's just this only. And for B equal to, again like that, you have to find 0.3085 to the power 2, 0.6915 to the power 3. And that also, how many arrangements are there? That of course I don't even want to arrange. Okay, like this for these also you have to do. You see it's very time consuming. So then in each and every one of these paths, there's at least one negative. The only path that doesn't have any of the negatives is when all of them are positive and 0. When all 5. So are there any arrangements when all of them are exactly the same? No, this is the only path that we don't need. This is the only path that is not required in here. So getting one value greater than or equal 0 is 0.6915. So because there are 5 values that are following the same path, it's 0.6915 to the power 5. This is the probability that we don't need. So we subtract it from 1. Total probability 1. Subtracting from the probability that we don't need gives us the probability of all the other paths that we need. Okay. Probability that is greater than or equal, because negative means we found that it's less than. Actually, yeah. Okay. It's yeah. Okay, so positive. Actually, here this is actually continuous data, right? Yeah, continuous data. So equal mark being here, not being here does not actually make much of an impact for continuous data. It makes a big impact for discrete data. Okay, so I hope you guys were able to understand what I'm talking about here. Question number 6. Students on a psychology course were given a pretest at the start of the course and a final exam at the end of the course. The teacher recorded the number of marks achieved on the pretest is P and the number of marks achieved on the final exam F for 34 students and displayed them on a scatter diagram. Okay. The equation of the least squares regression line for these data is found to be, okay, F equal, they have given in the regression line. For these students, the mean number of marks on the pre-test. So for P, the P bar value is given. Part A, P bar value is given as 62.4. They are asking you to find the, use the regression model to find the mean number of marks on the final exam. So that means you have to find F bar. How do we use this equation to find F bar? It's simply like using coding, right? We can write the equation F bar equal 10.8 plus 0.748 into P bar. Do you understand? So F bar equals 10.8 plus 0.748 times P bar. Input the P bar value and multiply and tell me the answer. P bar is 62.4. What is the answer? Yeah, tell me. Type in the chat. Get me the answer quickly. How much is it? Is it 7.475? Have they told you? Yeah, use the regression model to find the mean number of marks. Yeah. Can I have the fraction answer? 35,000. Which became 57.4752. So basically, it's 57.5. Okay, so 3 years. So anyway, I have the exact numbers written in an event if I want for the next part. So I have the exact figure. Okay. Then let's go for the next one.
Yes.
Okay, let's go for the next part. So part B, they ask you given interpretation of the gradient of the regression line, 1 mark. So how do we interpret the regression line gradient? So that was the format that I gave you, right? So the format I gave you was to interpret the gradient. When x increases by 1 unit, your y increases by the gradient. Do you remember? So all you have to do is just replace the xy with the words they have used in the question. So when x increases by 1 unit, the y increases by the gradient. So what's the x here? X is the pretest, right? So X is the number of marks achieved on the pretest. So what happens? So when your pretest, so for every extra mark you achieve on the pretest, for every additional mark, right? Isn't it? So for every extra additional mark, 1 mark. For every additional mark you receive on your pretest, what happens? Your y. Who is your y? The y means the final mark. The final mark will increase by the gradient. How much is the gradient? Your gradient is 0.748. Okay, so that's it. Just follow the format. It's given to you in the book also. So part B, for each additional mark, for each additional or for each 1 mark, or for each extra mark you achieve, for each additional mark scored for the pretest, for each additional mark you score on the pretest. So when your x increases by 1, what happens? Your y increases by the gradient. Who is your y? The final mark. The final mark increases by the gradient. Who is the gradient? 0.748. Okay, so this is it. Whenever they ask to interpret gradient, just remember the format I told you. When x increases by 1, y increases by gradient. That is if your gradient is positive. In an event, if you have a negative gradient, you will say when x increases by 1, y decreases by the gradient if your gradient is negative. Okay. Then the next one, considering the equation of the regression line, Priya says that she would expect someone who scored 0 marks on the pretest to score 10.8 marks on the final exam. Comment on the reliability of Priya's statement. So what do you think about it? Okay, now how do you check on the reliability? Now how do we even get this point called 10.8? So 0 marks for the pretest means when p is 0. So I think obviously what she's doing is she's making this line longer and it cuts somewhere over here. Okay, she has made the line long and cut somewhere over here. And then based on that only, they have said, okay, 0 marks for the pretest means you will get 10.8 for the final. So they are asking on the reliability. Do you remember this reliability, interpolation and extrapolation? If your data, if the data values, if you are making a prediction for the data values in the given data inside the data set, then it's reliable. But if you try to make a prediction outside of the given data set, then can we rely on that? Now look at the data that we have sampled, the pretest marks that we have taken. What's the lowest pretest mark we have? I think the lowest mark we have is, this is 10, right? The middle. Each square represents 2 marks. Can you see? So the lowest we have here is, I think, yeah, this cross, which is how much? 19. It's in the middle of the square. The lowest mark we have is 19. So we are okay to predict until 19. But can I predict anything below 19? No. Okay. So then you can say here, comment on the reliability. What would you say? The statement is reliable or not? The statement is not reliable. Why? Because there are no data points below. There are no data points below 19. Or you can say it's extrapolation. Okay, the statement is not reliable. The statement is not reliable. The statement is not reliable since there are no data points. Since I'm just writing everywhere, okay, since there are no data points below, what's the lowest point we have? 19. So there's nothing below 19. So I can't go below 19 at all. We cannot do any prediction below 19. Okay, all predictions can be done inside the data range. Next one, write down the number of marks achieved on the final exam for the student who exceeded the expectation of the regression model by the largest number of marks. Okay, think about this one. You need to look at the regression line also, right? Write down the number of marks achieved on the final exam. Write down the number of marks achieved on the final exam for the students who exceeded the expectation of the regression model by the largest number of marks. So basically now the regression model gives you how the data should behave. For the final mark, for the pretest mark, they give you the predicted final mark. So they are asking, who is the student? Write down the number of marks achieved on the final exam for the student who exceeded. Exceeded means what? Did they score less or more? They scored more. They scored more than what was predicted by the regression model. So the regression model gives you for each p-value, for the p-value they scored on the previous, the pretest, it tells you how much you will score for the final test. So they are asking you to look at these points and tell which one exceeded the most and by how many marks did it exceed. So first what you do is find the point that they are talking about here. What's the point they are talking about? Now look at the individual marks. I think you can see the crosses that are below the line means what? Any cross that's below the line means they didn't perform as expected. Their final mark is less than the predicted mark. So now we want the person who exceeded the expectations by the most number. So look at this one. Now these guys are also, you can see they have exceeded these crosses over here. Can you see they have exceeded the expectation? Now the thing is you have to see which one has exceeded by the most value. So if you, by the way, it means you check this gap. Which one has the highest vertical gap? Do you get what I'm saying? Do you see which one has the highest gap when you look at all these? I think you can roughly see it from your eyes. Which one do you think has the highest gap? Which now the predicted value, but the real value is a lot more than that. So I think we can see it's this cross. Do you see? Because this has the highest gap. See, the predicted value is somewhere over in 50. It's somewhere like 56. The predicted value is 56, but you end up getting somewhere like what? We end up getting a 76. So all the others are, I mean, I think when you take the other crosses above the line, they don't have such a big gap. You see, it's the gap, what we expect and what we get. So the expected value was here, and what the student achieved was over here. So this one overachieved. This one exceeded the expectation by the most amount. I think it's more significant than the others because the others gaps are more smaller. This is the largest gap you have. Do you agree with what I'm talking? Okay. Okay, so then we'll write down the answer. I'll erase the others. Okay, so it should be what? The answer for part C is the part D, right? Answer for part D is 76. 76 marks. The student achieved 76 marks and he's the person who exceeded expectations the most. Do you agree with me? Okay, let's go for the next part. Okay, so I took the part E over here because I want to keep looking at my regression line. Okay, look at this. The next one they say find the range of values of P for which this regression model f equal to 10.8 plus 0.748 P predicts a greater number of marks on the final exam than on the pre-test. Okay, once again what? They are asking you to find the range of values of P, that is the pre-test mark. Range of values of P for which this regression model predicts a greater number of marks on the final exam than on the pre-test. Okay, think about this. Yeah. So they want the range of values of P where the regression model predicts a greater number of marks, right? The regression model predicts a greater number of marks on the final exam than on the pre-test, which means what? They want the final mark to be what? They want the final mark to be greater than what? The final mark needs to be greater than the pre-test. Are you with me? The final mark needs to be greater than the pre-test. So F value, now the F equation is given to us, right? See, what is the F equation? 10.8 plus 0.748 P should be greater than P. Do you see? So we can get the range by doing this. This is the way to get the range. Otherwise, it's you can't just think about it. Okay, so the range of values of P where the final mark is greater than the predicted. Yeah, greater than the pre-test. So P minus 0.748 P, how much is it? Subtract 1 minus 0.748 is 1 P. 1 minus 0.748 is 0.252. So here we get P is less than 10.8 divided by 0.252. So what is the range of the P values? P less than what? 42.8571. So these are the P values according to your model. Okay, not according to the graph, but the scatter points, but according to the regression model. Okay, now when you are using this regression model, the regression model will give for P values less than 42.8571, it will give a greater mark for the final exam than for the pre-test. Okay, so that is happening entirely from the straight line. Okay, so basically P less than 42.9 when you correct the 3SF. Yeah. Find the range of values of P. Okay, then let's move on to part F. Part F. Later, the teacher discovers an error in the recorded data. The student who achieved a score of 98 on the pre-test scored 92, not 29 on the final exam. Okay, they are saying this scatter plot has a small error. So what's the error? The teacher discovers the student who achieved a score of 98 on the pre-test scored 92, not 29 on the final exam. Okay, so then the summary statistics used for the model F equal 10.8 plus 0.748 are corrected. So they are correcting this now. Obviously, we are correct to include this information, and a new least square regression line is found. Given the original summary statistics were these, calculate the gradient of the new regression line. Show you are working clearly. Okay, they are asking you to calculate what? Only the gradient. They are asking you to calculate the gradient. Okay, how do we calculate the gradient? Okay, so this is a quite a thinking part here. Okay, they are asking you to calculate the gradient of the new regression line. Show you are working clearly. So here I have marked the point that the teacher has made the mistake. Now the teacher has said, now they say here the student who achieved a score of 98 on the pre-test. Do you see this point? This is the point that they're talking about, right? This point where the person has 98 on the pre-test, it shows for the final exam they have 29. So that is the error. It should be 92, not 29. Okay, so then now first thing you need to realize is what values are changing and what values are not changing. That's the first thing you need to understand. Listen. The first thing is you need to realize the pre-test marks, are they changing in any way? The p-values are not changing, which means do I need to change sigma p? Do I need to change sigma p? No, sigma p is fine. Do I need to change SPP? Now, you know, SPP is made from sigma p square minus sigma p whole thing square over n. Nothing is changing in the pre-test. Pre-test marks are completely fine. So what are the things that we need to find new? The things that we need to find in new is the sigma PF will change now. The sigma PF value will change. This is problematic. This is wrong now. And SPF is also going to be wrong. So these are the two things that are going to go wrong, and we need to find those two values first. Okay, first thing I'll do is, okay, we'll find the, now they ask us to get the gradient of the new regression line, right? So what's the gradient of the regression line? Normally the gradient of the regression line is found as SXY over SXX. In this case, X is P, right? So SPF over SPP. Are you with me? Gradient is, the gradient of the regression line is found by this formula, SXY over SXX. In our case, our X variable, the independent is P, pre-test mark. Final Y independent is F. So I have to find, to get the gradient, I need to find the SPF over SPP. Now you know SPP value is the pre-test mark, so that doesn't change, that I have. That is already there. The only thing I need to find what? I have to find the SPF. Are you with me? SPF value needs to be found. Okay, how do I find the SPF? Can you all tell me the SPF equation? SXY equation, right? So it's sigma PF minus sigma P into sigma F over N. This is the equation, right? Okay, so I have to calculate some things here newly. So sigma PF should be found and sigma F should be found. Are you guys with me? Now, let's get the sigma PF here. Now, what was our, now sigma PF means what? You take the pre-test mark and the final test mark and you multiply. That is P into F. You take the P value, the F value for each and every single point here. They've taken the P value. For each and every single point, they've taken the P value, F value and multiply. And then you add. The next P value, F value, you multiply and you add. So you keep on taking the product of P and F for all these points and you add. Now, you know, there is one point who has an error, right? Only this point has the PF product of, only this point is wrong. Do you get me? So what I'll do here is I will subtract to get the correct sigma PF. What will I do? Now my previous PF product answer was 133,486. Here I multiply the P value and F value of every single point and add. So from here, let's remove the point that's wrong. So let's remove the product of the point that's wrong because we have included that wrong product here. So what is the product that's wrong? The PF product that's wrong here is 98 times 29, right? Because we multiply P and F. So 98 times 29 is the product that's wrong. So subtract the 98 times 29. That removes that particular point. And what do? Add the new point. Who is the new point? Plus, now we add what's the new point? The new point, again, the pre-test P value is 98. What is the final mark? For 98, the final mark is 92. We removed the wrong one. 98 times 29 product was the wrong one. We subtracted it. Okay, and then we add the new one. This gives the corrected sigma PF value. Are you with me? How much is that answer? Can you all calculate me the new sigma PF value? Quickly calculate. So I get 139,660. This is the new sigma PF product. 139,600. This is the correct one. We fixed the error that the teacher has made, and now this is the corrected PF value. We subtracted the wrong PF product and added the new PF, the correct one. Do you get what I'm doing? Yeah. Then to find SPF, okay, my sigma PF is now corrected. Who else do I need? Sigma P do I need to correct? No, sigma P is correct. Then what about sigma F? Sigma F is when you add all the final marks. So is my sigma F value correct? No, right? Because for sigma F, we have added that wrong value 29. So that means I have to, from the sigma F, the value I have, now I have a sigma F value. From that, I have to subtract the wrong value 29 and add the new value 92. So do we have the sigma F value anywhere in this question? So we have found in here, they haven't given us sigma F, right? Even in these parts, have they given us sigma F anywhere? No, right? Sigma F is not given. So what's the closest thing to sigma F that we found? Please check. We have found F bar. Do you see, children? We have found F bar. That's the closest we have to sigma F. So write F bar. So who is F bar? F bar is equal to sigma F over N, right? So can't I find sigma F now? What was the F bar answer? Please remind me again. The full value? Yeah, tell the decimal. 57.4752. 57.4752 equals sigma F over what's our N value? We have N is 34. Get the sigma F here. Multiply 57.4752 with 34. How much is sigma F? Multiply quickly. 57.4752. We multiply with 34 and we get 1954.1568. Am I correct? This is the value I get, 1954.1568. Now, let's get the corrected sigma F. So how do I get the corrected sigma F? From this figure, 1954.1568, I subtract the wrong F value. The wrong F value is 29, right? I subtract the 29 and I add the new value, because in this summation for this sigma F, we have added it with the 29. We have added the wrong value. So we remove the wrong value and add the new value. Okay? Is that okay? Can I have the answer here? How much? 2017 point how much? Minus 29 plus 92. 2017.1568. So this is the corrected sigma F. Now can't you find SPF? The corrected SPF. The corrected SPF is sigma PF minus sigma P sigma F over N. So give the corrected value. Sigma PF now is we found 139,660 minus sigma P is, sigma P was it didn't change, 2120 into sigma F is 1954.1568 over N value is 34, right? Sorry, corrected sigma F. Yeah, I used the corrected sigma F, right? No, corrected sigma. I have used the corrected sigma. Corrected sigma is 2017.1568. Yeah, we had used the corrected sigma F value. I used the other one also, the corrected sigma PF, right? This is the corrected sigma PS. Okay. Corrected sigma PF. Okay. So now type the whole thing in the cal and get the SPF value. How much is SPF? 139,660 minus 2,120 times 2017.1568 over 34. So I get something like this. 138. This is okay. I have used all exact figures here. Okay, 130, 13,884. Am I correct?
Is that BPF minus that sigma PF minus sigma PF?
Sigma PF minus sigma P sigma F over N. This is the equation for SPF. Now get the gradient. So the B value. The new gradient will be, can you see when a single point changes the line is shifting. So we get here. So the new gradient will be how much? SPF is 13,884.34071 over SPP doesn't change, 15,573.76. Divide and tell me the answer. How much is it? Zero 0.8915. Something like this. So they give any answers that round off to 0.9, because basically some you might not take this many decimals, right? You might take, if you all take a little bit less decimals, it's fine. So they give you the mark as long as it rounds off to 0.9. Your answers are correct. Okay. This is the sigma P. SPP. SPP is 15,573.76. The gradient is SPF divided by SPP. Okay, so this is the answer for the new gradient. Question number 7. A bag contains n marbles, of which 7 are green. From the bag, 3 marbles are selected at random. The random variable x represents the number of green marbles selected. Okay. The cumulative distribution function of x is given. Okay. So this is capital Fx. Do you see? Cumulative means you add the previous probability. So when you say x is 0, that is only the x0. But when we say x is 1, they add the probability x0 and x equal 1 and give you. So in cumulative distribution functions, you know, definitely the final probability is definitely 1, because you add all the previous probabilities. They are asking you to show that n times n minus 1, n minus 2 is equal to this. Okay. Okay, how do we get this one? The first thing I notice here is, okay, with A and B, I can't do anything. However, I can, they have given me the probability, the total probability until x equals 2. And I have the total probability until x equals 3, right? So basically, they have given me capital F2. Capital F2 means all the probabilities until 2. 0, 1, and 2. The probability for F2 is how much? 37 over 38. And they have given me F3. F3 is 1. That is the probabilities from 0, 1, 2, 3. So, using these two, what can I find? Using these two, what can I find? From F3, the total probability, if I subtract F2, F2 means the probability is 0, 1, 2. What do you think I will get when I subtract these two? The F2 represents here, F2 here represents the individual probability when x is 1, x is 0, when x is 0, when x is 1, and when x is 2. This is what F2 represents. F3 represents the individual probability when x is 0, x is 1, x is 2, and x is 3. Okay. So then, when you subtract these two, can't you see what's happening? From F3, when you subtract F2, these parts will cancel, and do you see only the probability x equal 3 is remaining. So basically the probability that x equal 3 is how much? 1 minus 37 over 38. From the total probability, when you subtract these three probabilities, you get the probability, individual probability that x equal 3. Okay, how much is it? 1 over 38. 1 over 38. So this is the individual probability of x equal 3. What is x equal 3? So x equal, the bag contains n marbles, of which 7 are green. Okay. From the bag, 3 marbles are selected. Read the question again. The random variable x represents what? The number of green marbles selected. So basically, I have here the probability that x equal 3. I have the individual probability. Now in F2 also, I don't have the individual probability. The only individual probability I have is for x. X equal 3 means I have taken what? 3 green marbles. So can't you write the probability of taking 3 green marbles? So what's the probability of taking 3 green marbles? Green, green, green. Now we know there are 7 green marbles. Out of how many? Total number of marbles inside the bag is n. Okay, you have n marbles. Out of them, 7 are green. Out of n. So what's the probability of taking the first green marble? You have 7 chances out of n, because there are 7 green marbles and there are total n marbles. So you take the first green marble out. Okay, then again, what's the probability of taking the next marble? You have, yeah, they're not replacing. You have 6 chances out of how much? N minus 1. Then for the third marble, to take a green marble, what's the probability? You have 5 out of n minus 2. So this is the probability of taking 3 individual green marbles. And don't we know this answer? The probability x equal 3 is how much? 1 over 38. So simplify, children. 7 into 6 into 5. 7 into 6 into 5, and 38 shall I bring to the other side? Equals n into n minus 1 into n minus 2. Do you see I brought these 3 to the other side as a multiplication? So how much is 7 times 6 times 5 times 38? 7980. Did you multiply? 7980 equal n into n minus 1 into n minus 2. So this is the answer for part A, right? Can you see we got the show there? So then they're asking you part B, verify that n equal 21 satisfy the equation in part A. So verify means what? Simply do what? Replace n value with 21 and show that the equation is correct. So verify n equal 21, replace n with 21, n minus 1, n minus 2. Replace n with 21 into 21 minus 1 is 20 into 21 minus 2 is 19. Substitution, what do we get? How much? We get 7,800, 7,980. Children, what does it mean? It means 21 is a possible total number of, n equal 21, which means 21 is a possible solution for the number of marbles in the bag, because the bag contains n marbles. So when n equal 21, this is working out, which means n equal 21 is a solution. Okay. Okay, then they have told you next one, given that n equal 21, find the exact value of A and the exact value of B. Okay, so let's get this one. Given that n equal 21, find the exact value of A and the exact value of B. So how do we do this? Part C, the exact value of A. So what do we get now? I think you understand for the very first probability. Okay, the cumulative F0 value and the individual x equals 0 value are the same. Do you agree? Because F0 means you add all the probabilities before this. But do we have any probabilities before 0? No, so F0 is the same as probability x equals 0. Isn't it? Because in cumulative, always the first column for probability and cumulative are the same. Because we don't have anything previous to add. So what do you mean when x is 0? Now you know you are taking 3 marbles from the bag. So x is 0 means what? X is the number of green marbles you take, right? X represents the number of green marbles. So x equals 0 means all 3 marbles are what? Not green. X equals 0 means there are 0 green marbles. Okay, so you take 3 marbles, out of 3, 0 are green, means all 3 are not green, which means It's in other words, not green, G dash. Shall I put G dash? G dash means all three are not green. So can't you find this probability all three are not green? What's the problem? Now we know there are 21 marbles in this bag. So if there are 21 marbles inside the bag, the end value is 21. Then how many are not green? If 7 are green, how many are not green? We have not green marbles. There are G dash, there are 14 not green ones. Okay, so what's the probability of taking the first not green marble? You have 14 chances out of 21. Next not green one, 13 out of 20. Next not green, 12 over 19. Multiply and tell me the answer. 14 over 21 into 13 over 20 into 12 over 19. How much is the answer?
I get 26 over 95.
26 over 95. So this 26 over 95 is in other words what? This 26 over 95 is in other words what? It is the value of your A. The individual probability x equals 0 or f0. This is your A value. Do you understand? But okay, to get the B value, what we'll do is this. Let's get the probability x equal 1. Individual probability x equal 1 means what, children? Individual probability x equal 1 means from the 3 marbles, 1 is green. So from the three marbles, 1 is green. So 1 is green, the other 2 are not green. So is this the now? You can see when we have something like this, is this the only part we can consider? No, right? You know, when we are taking colors like this, green and 2 not greens, we have to consider all the possibilities, which means what? The arrangements. How many ways can I get 1 green and 2 not greens? We can arrange this in 3 ways. Do you see G dash, first not green, then not green. Again, not green, and green. We can arrange this in 3 possible ways. Do you understand? So because of that, what you do is you can find the probability of one part and multiply by 3. So what's the probability of getting a green? Tell me the probability of getting a green. We have how many? 7 chances out of 21 to get a green. The next one, so we have taken 1 green marble out. Then not green, we have 14, right? So next 14 out of how much? Is it 21? No, it's 20 because you have taken 1 green marble out. So 14 out of 20. Next not green marble is 13 out of 90. Do I need to find the individual probability for these 2 parts? No, just take the probability of one part and multiply it with 3. So this is the probability of x equal 1. How much? What's the probability that x equal 1? 91 over 14. Check again. 91 over 190, right? So multiply. Okay, this probability is 91 over 190. Then I'm given the probability x equal 1. Now, does this mean that this is my B value? What is B? B is the cumulative probability, right? When so F1 is B. That means F1 means we have the probability x equals 0 and x equal 1, right? To fill this column here, to fill this value here, we add the individual probability of x0, x1 and we fill this value, isn't it? B value. So B value is the individual probability of 0 and 1. So individual probability x equals 0 we found. It is 26 over 95. Individual probability x equal 1 is 91 over 190. How much is B? Add everything. 143 over 190. Okay, so this is the end of the paper. I hope all of you understood the concepts that we discussed.